Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syada binti Muhammad Supri and I'm going to present my progress on car wash effluent treatment, and my supervisor is Dr. Shafriza Sabri. So for introduction, nowadays there are uprising issues on the quality of drinking water. So for us, in order to get better quality of drinking water, the river quality should be enhanced, and to achieve that, proper discharge of effluent from industrial runoff to the catchment area must obey standard B regulation. And car wash effluent is one of the contributing factors that can affect the environment, such as the river. So it is generally perceived by public that car wash wastewater is not severely contaminated compared to the other heavy discharge from other industry. So as for that, the objective of the project is first to study the characteristic of car wash effluents, and next to investigate the efficiency of using commercial and biomass waste as adsorbents in removing contaminants in car wash effluents. So the literature review for this project are: this is the summary of previous study for car wash wastewater treatment using adsorption technique, and different researcher use different type of adsorbents. So the first researcher used granulated activated carbon, and it shows 60% detergent removal for adsorption treatment. And the second researcher used bioadsorption method, and it apply sawdust from pine trees, sugarcane bagasse and coconut coir fiber as the adsorbent material without any chemical modification, and it shows excellent removal of COD and BOD. And researcher also compare efficiency between sawdust and sugarcane bagasse as adsorbent, and it is proven to be sawdust show higher average removal of 89.6% for COD. Okay, this literature review shows the performance of Concorp in removing contaminant in different type of wastewater, and the first can be seen is automobile wastewater service center. This type of wastewater contain high amount of oil and grease, but by using the Concorp as adsorbent, it can remove up to 70 to 80% of oil and grease. And for contaminated wastewater, the researcher compared the performance of Concorp charcoal, activated Concorp and ash, and it is proven to be that the Concorp is the best adsorbent for cadmium to remove cadmium ions, and the activated Concorp is the best adsorbent for lead ion to remove lead ions, and ash can remove turbidity. And for industrial wastewater, the researcher used Concorp as the adsorbent with chemical modification of HCl to eliminate heavy metals, total dissolved solid, total suspended solid, and COD. And all of that shows good removal of contaminant, as the total removal of COD is 56%, total removal of total dissolved solid is 65.7%, and for TSS it is 83.3%. And for domestic effluents, the researcher built a filter system consists of raw Concorp that is cut longitudinal and smaller section, and it also have filter media of powdered Concorp and also filter media of charcoal Concorp. And the final filtrate shows that it is able to remove removal BOD of 66.1%, COD 66.17%, suspended solid at 53.2%, and turbidity removal efficiency of 57.14%. And the visual of detergent, oil and grease and colored dye is absent after the filtration process. For the methodology of this project, first step is preparation of adsorbent. It involves pulverization of Concorps to form powdered Concorp, and then the carbonization of sample by pyrolysis to form Concorp charcoal. And then after that, the next stage is characterization of adsorbent. There are two analyses involved, which is EDX and BET. So EDX is used to determine the elemental composition in the charcoal, and for BET it is used to determine the total surface area for all four of the adsorbent. And then it proceed to the batch adsorption study that have three different variables, which is we want to see the effect of size adsorbent and the effect of dosage and also effect of temperature on the adsorption process. So for the method of pulverization of concocts in order to make powdered concocts, so first the concocts were obtained at local market, and then it is washed and rinsed with distilled water, and then after that it is sun dried to remove the moisture. After that, it is cut into small pieces to easy the grinding process. Then it undergoes several grinding process to make it into powder form. After that, it is sieved at 300 and 212 micrometer sieve tray. It is then heated in the oven for 10 hours at temperature of 105 degrees Celsius, and it is cooled and stored in the desiccator. For the method of pyrolysis of concocts, so 30 grams of powdered concocts is obtained from two different sizes, which is lower than 212 micrometer size and also 212 to 300 micrometer size range of size of adsorbent. Both were heated in furnace with limited air and with variation of temperature, which is 550 degrees Celsius and 750 degrees Celsius for half an hour. And then the charcoal is washed with warm distilled water until neutralization. After that, the charcoal is filtered and dried in the oven for 10 hours. The charcoal obtained is cooled and stored in the desiccator until used. For commercial activated carbon, we buy the activated carbon from the supplier, and as we obtain a granulated activated carbon, so we grind the granulated activated carbon to powder to decrease the particle size, and then the powdered activated carbon are sieved at 300 micrometer and 212 micrometer to get fixed particle size with powdered concocts, and then it is stored in desiccator until used. We'll proceed with the result and discussion. First, the result for car wash wastewater characteristic. This is the sample of car wash wastewater to show the appearance of the car wash wastewater effluent. For car wash wastewater characteristic, the selection of car wash was happened at 3 different car wash stations, and the average effluent, the range of effluent concentration are shown in the table, and it can be seen that the range of effluent concentration is compared to the standard B limiting concentration, and it is analyzed that the chemical oxygen demand show higher concentration rather than the limiting concentration, and also total suspended solid also show higher concentration rather than standard B limiting concentration. Characterization of powdered concoct, activated carbon and charcoal concoct. All of the adsorbent are sent for BET surface area, and to determine the total surface area of the adsorbent, and all of the adsorbent were sent to the lab for BET analysis. And for EDX, it is shown in the table the quantitative analysis of element based on EDX for concoct charcoal at 550 degrees Celsius, and it shows that the element of carbon is the highest, had the highest amount of weight percent, which is 90.51, and it also has oxygen content of 3.51, and the amount of magnesium oxide, silica oxide and potassium oxide is present. And that is the EDX image of Concob charcoal at 550 degrees Celsius. And this is the table for quantitative analysis of element based on EDX for Concob charcoal at 750 degrees Celsius. And as you can see, the weight percent of carbon is lesser than the weight percent of carbon in the charcoal Concob for 550 degrees Celsius, as the element carbon only have 84.44% per weight, and the oxygen content is 6.14%, and it is proven by calculation that the magnesium oxide, silica oxide and the potassium oxide, the amount of all of these minerals oxide is higher in carbon in charcoal Concob at 750 degrees Celsius rather than Concob charcoal at 550 degrees Celsius. So for batch studies for adsorption, there is 4 types of adsorbent that is going to be used, and it is categorized as 2, which is industrial adsorbent and biomass waste Concob based adsorbent. And biomass waste Concob's based adsorbent will be divided to powdered Concob, charcoal Concob at temperature of 550 and charcoal Concob at temperature of 750 degrees Celsius. And for industrial adsorbent, coconut shell activated carbon was chosen as the industrial scale activated carbon, and this type of activated carbon is used for wastewater treatment in industrial scale. For the batch adsorption study, the first variable that is going to be investigated is effect size of adsorbent. So as we can see from the graph at the left side, that is the graph for COD removal at dose of 2 gram, and the right side is for TSS removal, and both removal of COD and TSS were higher when the smaller particle size were used regarding of the type of adsorbent that is being used. And for COD removal, the adsorbent in the size range of lower than 212 micrometer was superior to that adsorbent with such size range of 212 to 300 micrometer. And for PCC and AC show deviation in result, as the greater size of particle show higher removal of TSS, but still the maximum removal of total suspended solid was achieved by particle size range of lower than 212 micrometer for both type of charcoal. Effect dose of adsorbent. So first I will explain about the powdered Concob situation. So powdered Concob dosage of 0.5 gram give the highest removal of COD, which is 57.14%. However, the effluent obtained after the adsorption process show presence of yellowish color, which come from the powdered Concobs. So the color is one of the limiting parameter that is present in the standard B, and color also can limit the penetration of light in the river. So it is conclude that powdered Concob is not preferable as the adsorbent to treat car wash wastewater. Then effect of those adsorbent. So this is the graph of to show the effect of dose adsorbent for COD removal at size of particle less than 212 micrometer. So the adsorbent CCC 550 show different trend of result, as the maximum removal of COD achieved was at dose of 2 gram rather than 4 gram. So the percentage removal differ around 6.25%, as the removal of COD at dose of 2 and foreground were 68.75% and 62.50% respectively. So the increasing dose of adsorbent actually increased the availability of binding site for the contaminant to make contact with during the adsorption process. And Concord charcoal shows better result than activated carbon, as the maximum CO2 removal that is achieved by activated carbon only 64.29%, while for charcoal Concord at 550, it has maximum CO2 removal of 68.75%, and for Concord charcoal at 750 degrees Celsius show maximum removal of COD at 83.33%. So this is the table, the graph of effect dose of adsorbent for TSS removal at size of particle less than 212 micrometer, and then percentage removal of TSS for Concord charcoal surpassed the TSS removal of activated carbon for every dose of adsorbent tested. And as the adsorbent dose increased, the removal of TSS also increased. However, the maximum removal of TSS achieved was just the same for both Concord charcoal at 550 and Concord charcoal at 750, which shows that the Concord charcoal at 550 degrees Celsius is better than Concord charcoal at 750 degrees Celsius in removing TSS. So the effect of temperature, for Concord waste, the heating temperature, it is investigate that it can be conclude that the heating temperature of 550 degrees Celsius is more suitable, as it produces higher weight percentage of charcoal compared to the heating temperature of 750 degrees Celsius, and this can be proven at the EDS analysis results. And so this can be explained as the exceeding heating temperature can cause further degradation of hydrophobic substance, which is the carbon structure generated in the charcoal. And it is also had been measured that the maximum amount adsorbed per unit weight for charcoal Concord at 550 degrees Celsius is higher, which is 8.8 milligram per gram, compared to the QE of the Concord charcoal at 750 degrees Celsius, which is 8 milligram per gram for the removal of chemical oxygen demand. And for the ability of the Concord charcoal to absorb contaminant in car wash wastewater decrease if the temperature used for the pyrolysis is too high. So for the conclusion of this project, first the analysis shows parameter of COD, which is chemical oxygen demand, and TSS exceeding the limiting parameter set by standard heat. And based on the study, the preferable type of adsorbent is charcoal Concord at 550 degrees Celsius, with optimum size of adsorbent investigated is size range of lesser than 212 micrometer, and the ideal dose of adsorbent was 2 gram per 100 ml of car wash wastewater to obtain the QE of 8.8 milligram per gram. And for the recommendation, first, the PCC could undergo several washing to eliminate the color before further analysis. And also, second, the further study can be done by modeling a fixed bed adsorption column as pilot scale of the car wash wastewater treatment unit. So the optimization and of contact time and depth of concords can be determined by lab scale of fixed column study. From me, thank you.